Okay, guys. So yeah, let's get started without any further ado. As mentioned in today's class, we're going to go with a few more advanced concepts in networking fundamentals. Okay. So we have covered up to what public and private IPs are in the last session. Today we'll talk about the classes. Okay. So as mentioned, there are 5 separate classes in the entire IPv4 range. There's class A, class B, class C, class D, and class E. Class A starts at the first IP 0000. Class E ends at the last IP 255, 255, 255, 255. And it's important to remember these ranges, guys, because these have been created by the people who invented IP addresses and they are going to remain constant. These are fixed ranges. These values will never change. Okay. And it's very important that you remember these ranges. Okay. And there's a simple way to remember them as well. Nothing too complex, guys. Class A starts at the first IP, 0000, and it goes up to 127, 255, 255, 255. Okay. Since it's ending at 127 and the remaining 3 octets are 255s, class B automatically starts at 128,000. Okay. So all the 255s cycle back to zeros and the 127 leftmost octet increases by 1. Okay. According to the same logic of the sequence of IPs that we learned yesterday, we have the next IP here. Okay. Now, class B starts at 128 and goes all the way up to 191, 255, 255, 255. Since it's ending at 191, class C starts at 192. From 192,000, it goes up to 223, 255, 255, 255. And since it's ending at 223, class D starts at 224. From 224,000, it goes up to 239, 255, 255, 255. And since it's ending at 239, class E starts at 240. And from 240, it reaches up to the last IP address 255, 255, 255, 255. So on the on the left side, in the last 3 ending octets, you have all zeros. And on the right side, at the ending range, you have all 255s. Okay. So you only have to remember these 4 IP addresses. So the number 127, 191, 223, and 239. If you remember these 4 numbers, you automatically get the range of the next IP. Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, and Class E 240 to 255. Okay. And again, in each class, there's a separate private IP range. Okay. So if you remember, each of these classes has 2 categories of IPs, public and private, except for Class D and Class E. All of them are public IPs itself, right? So we talked about that yesterday. Okay. So, excuse me, I'm a bit sick today. So Class A starts at the, again, between the range of 0 and 127. The first private IP in Class A starts at 10,000, and it goes all the way up to 10, 255, 255, 255. So this entire range of IPs in Class A is a private IP range. Any IP within this range is a private IP, which means it can be used in your local network. And any IP outside this range is a public IP, which means it belongs to the ISP for public internet connections. Similarly, in Class B as well, between 128 and 191, there's a small range 172.16.00 to 172.31.255.255. This is the private IP range in Class B. Any IP within this range is a private IP. Any IP outside this range is a public IP again. And similarly, in Class C also, between 192 and 223, there's a small range 192, 168.00 to 192, 168, 255, 255. Any IP within this range is a private IP, and any IP outside this range is a public IP again. And in Class D and Class E, there are no private IPs at all. All of them are public IPs itself. Now, these are not just any random numbers, guys. These have been created by a value called parity bit. That is not important for us right now. It's too in depth of a concept. Okay. But you have to remember these values. Okay. Now, excuse me. If if you still find it a bit confusing, we can understand with the one example here. Okay. So if I take the example of Class A, it starts at the first IP 0000 and ends at the number 127, 255, 255, 255. So this is the entire range of Class A. Okay. And in that entire range, there's a small private IP range from 10,000 to 10,255,255,255. So any IP within this range is a private IP. And any IP outside this range, which is from 0 up to 10, which is 9,255,255,255. And after 10, from 11 to 127, that's the other public IP set. So in every class, you would have a similar private IP set in between and two public IP sets on each side, one on each side. Okay. Is that clear, everyone? Priyadarshini, Sumit, Vaibhav, and Sanya. Any questions or doubts? Right. So if there's no questions, what we are going to do now is we'll perform a small exercise. Okay, where I'll write down some random IPs. Okay, and looking at these numbers, you have to tell me which IP belongs to which class and whether they are public or private IPs. Okay, so let me open up a notepad file. Let me just write down some IPs first. Yeah, okay. So let me just quickly write down some IPs here, guys. Hmm. Okay. So I've just written down some random IPs here, guys. I want you to look at these IPs here and the range here and tell me which IP belongs to which category. Okay. So let me give the answers for the first few ones, and then you can give me the answers for the others as well. Okay. So looking at this number here, let me maximize it a bit if it's too small. Okay, better. So looking at this number, 10, 20, 30, 40. Okay. So now when you look at the first octet here, 10, we can understand that this falls between 0 and 127. So therefore, this is a class A IP address. Okay. And once you know it's class A, you would focus on this range. For an IP to be a private IP in class A, first octet should be 10, and the remaining octets can be anything from zeros to 255s. Okay. So in our scenario here, the first octet is 10, and the other values are between 0 and 255. So this is a private IP. Okay. For an IP to be a private IP in class B, what's the condition? First octet should be 172. Second octet should be between 16 and 31. And the remaining two octets can be anything from 0 to 255s. And for class C, first octet should be 192. Second octet should be 168. And the third and fourth octets should be between 0 and 255s. Okay. So we have the next IP here. Oh, 1 second. Next IP is 192.168.0.10. So looking at this number 192, we know this is class C. It's falling here. Okay, and now since you know it's class C, we have to figure out whether it's public or private. So first octet is 192, second octet is 168, and that is the same condition satisfied here. So therefore, this is a private IP as well. Okay, looking at this first next number 1, 2, 3, 4. Okay, first octet is 1, so therefore this is class A. Okay, but is this a private IP? So first octet is 1, which is outside this range. So therefore, that's a public IP. Okay. So that is how you can categorize which IP falls in which category again. Okay. So now, can you give me the answer for the next one, guys? 150, 250, 160, 170. Which class and whether it's public or private?
Class B, private IP.
Class B, perfect answer. And this is a public or private?
Private.
Are you sure? 150, 250, 160, 170. So for this to be a private IP in class B, first octet should be 172 and second octet should be between 16 and 31. But here we have 150, which means it's outside 170. It's outside the private IP range. And therefore, this is a public IP, right? Is that clear, everyone? Why this is a public IP? Perfect. Moving on. Next IP we have is 142, 250, 193, 221. Which class and which category? Any answers? Okay, I did get a few answers in the chat box. They say this is class B. Perfect answer. Okay, so it's between 128 and 191. So therefore it's class B. Public or private, guys? Public. Correct answer again. Okay. So because it's not falling inside this range, it's outside the range. So therefore public. Next number. 172, 35, 45, 55. Okay, I've got one answer as class B private. Any other answers, guys? So definitely this is class B. 172 falls between 128 and 191. So this is class B for sure. But public or private? Yes, this is a public IP. Okay. Why is this a public IP? First number 172, that seems to match. Okay, that's perfectly fine. But the second octet is 35. 35 is outside the range between 16 and 31. So therefore, this is a public IP. Okay. Moving on. Next, 200, 100, oh, sorry, over here. 200, 100, 0, and 100. Which class? Class C and public. Perfect answer. So if you notice, this is 200. It's falling between 192 and 2.3. So therefore, this is class C. Okay. And in class C, for an IP to be a private IP, it should start from 192. But here we have 200. So therefore, this is a public IP. Next IP, 192, 192, 192, 92. Which class and public or private? Class C and public. Perfect answer. So the first octet is 192. That gives you an answer that this is class C. Perfect. And now looking at the second octet here, first octet seems to match, but the second octet is 192. That's outside the range. So it's not 168. So therefore, this is a public IP as well. Next number, 172, 32, 42, 50. Class B and public. So the first number is 172. So therefore, it's between 128 and 191. Therefore, definitely this is class B. And public or private, first octet seems to match 172. Second octet, therefore, other, but if you notice 32, it's outside 16 and 31. So therefore, this is also a public IP. Okay. Next octet, oh, sorry, next number, 11001. Class A, public. Perfect answer. So 11 is falling between 0 and 127. So this is class A. And again, for it to be a private IP, it should start with 10. but we have 11 here. So therefore, this is also a public IP. Okay. Next number, 192.169.0.10. Class C, public. Perfect answer. Next number, 224, 30, 40, 192. Oh, sorry. Class D and public. Perfect answer. Next number, 245, 123. Class E and public. Perfect answer. Next number, 49, 50, 19, 190. Any answers? 49, 50, 19, and 191. Yes, class A and public. Okay. One more IP, let's say 172 and let's say 20, 30, 40. Yes, class B. And this is a private IP. Why is this private? Because the first octet is 172, that seems to match. Second octet is 20, which is between 16 and 31. So therefore, that's a private IP. Okay. The remaining two octets can be anything from 0 to 255. Okay. Let's say 192, 168, 0.10. Oh, I think I've repeated that number. 192, 168.100.100. Okay. What about this IP? 192, 168, 100.100. Which class is this? And is it public or private? Class C and private. Correct answer. So this is class C because it's 192. And it's private because the first two octets are 192 and 168. Okay. Correct answers, guys. Okay. Now, if I have to show you my public and private IP, if I go to my browser, I've shown you how to check for them. So in your browser, if you search for what is my IP here, this shows me my public IP. Now, looking at this IP, can you tell me which class does it belong to, guys? 49, 204, 238, 31. 49, 204, 238, and 231. 49, 204. Which class is this, guys? Class A and public. Perfect answer. So if you notice, it is between 0 and 127, 49. So therefore, this is class A. And definitely it's a public IP because it's outside this range. And if I check my private IP on the other hand, if I type IP config, you can see I get 192.168.0.5. Looking at this IP, can you tell me which class does it belong to? 192.168.0.5. Yes, this is class C, if you notice, and it is definitely falling in this range, 192.168.0.0 to 192.168.255.255. It's between that range, and therefore it's a private IP. Okay, so this is how you can understand which IP belongs to which category, guys. Okay, so, but all you have to do is you have to remember these ranges, though. So by looking at an IP, when you are able to confirm whether it's public or private, you can also understand where the attack is coming from. Okay, if the attack, so in a log file, when you go through a log and if you see the attack has initiated from a public IP, it means the attacker was outside your network. He wasn't in your local network. The attack came from the internet. Okay. But if the IP is a private IP, it means the attack was from an internal network itself, from your own local network itself. So the attacker was in your same network. Okay. So that classification can make you understand the source of the attack. Okay. But the question that arises here is why do we have 5 separate classes? Why not just one single class with some public and private IPs? Okay. That's a very generic question that students usually ask. Okay. Because again, each of these classes has public and private IPs in them. So why not just one single class? Okay. The reason for the 5 separate classes is because every network has a different requirement, guys. So depending on the network requirement size, you have different classes. Okay. So to vary the size of the network, you have different classes again. Okay. So class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. Class D and Class E have all network portions itself. There are no host portions in. So as you're going down the line, network portions increase and host portions decrease. Class A has one network portion, Class B has two network portions, Class C has three network portions. Class D and Class E have all network portions itself. But what are these network portions and what are these host portions? What do they signify? Okay. To understand this, we take the first example of Class C, which has three network portions and only one host portion. Okay. So we all know the first private IP in Class C starts at 192.168.0.0. That's the same thing which I've written down here, if you remember. Okay. Class C first private IP starts at 192.168.0.0. Okay. And out of those IPs now, 192.168.0.0, the first three octets are network portions, and the last octet is the host portion. Okay. So let's leave aside this network and host portion for a while and come back to the sequence of IPs. So if you know if this is the first IP 00, what's the next IP? 01. Next IP 02. Next IP 03. Next IP 04. Okay. This goes on all the way up to 0255. After 0255, what happens? This 255 cycles back to 0, and this 0 now changes to 1. So you have 10, 11, 12, 13, which goes up to 1255. Then you have 20, 21, 22, 23, 24, which goes up to 2255. Okay, the cycle keeps on repeating. Now, what I mean by network and host portions are, as long as the host portion changes, it indicates a unique host in that network. So 0.1 could be my Wi-Fi router. 0.2 could be my phone. 0.3 could be my laptop. 0.4 could be my smartwatch. So each unique host portion value signifies a unique host. Okay. And all of these belong to the same network, the 192.168.0 network. Okay. So all of these belong to the same network, 192.168.0. And when the network changes, when this 255 changes back to 0 and this 0 now changes to 1, here the network divides. So network divides here. Okay. And whenever there's a division in the network, these devices now cannot communicate with the other devices in from different networks. Okay. So you need a router for that in between. Okay. These devices without a router also they can communicate with each other. So if you just connect all of these devices to a switch is a device which allows you to connect local network devices. Okay. So you can connect all of these devices to a switch here. So again, this is what a switch would look like. If I go to my browser and if I search for a network switch, this is what a switch is like. Okay. So it has multiple ports as such. Okay. And on each of these ports, you connect a LAN cable. And to the other end of the LAN cable, you can connect a computer. So this is what the representation is, as you can see. Okay. So when you have a switch like this, you can connect all these devices in one singular network. Okay. But if you bring a device like 1.1 and if you connect it to the same switch, it cannot communicate with the other devices. Even though if it is physically connected to the switch, it cannot communicate with these devices because it belongs to a different network. Okay. So the network portion gives the identity for the entire network. So this is the 192.168.0 network. Okay. And the host portion gives the identity for each unique host in that network. Host is nothing but the device. So 0.1 is my Wi-Fi router, 2 is my phone, 3 is my laptop. As such, I can connect a maximum of 255 devices here. Okay. And if I try to bring one more device like 1.1 in this network, it will not communicate because the network portion has changed. Whenever there's a change in the network portion, the network divides there. Okay. And now these devices are a different network altogether and they can communicate among themselves. Okay. So what the three network portions and one host portion in class C signify is that in each network now, you can connect a maximum of 255 devices. So from 00 to 0255, these are 255 devices. 10 to 1255, 255 devices. 20 to 2255, another 255 devices. So in each network like that, you have a maximum of 255 devices. Okay. So in our home networks where we won't have a requirement of connecting more than 255 devices, In such places, you go for class C. That's why even in my network as well, if I open up my command prompt, you can see my device is getting a class C private IP, 192.168.0.5. Okay. And my router, which is called default gateway 0.1. Okay. And these two are the devices belonging to the same network, 192.168.0. network. Okay. And they are able to communicate with each other. Okay. So if I run a command like ping is a command to check connectivity. So if I type ping 192.168.0.1, you can see I'm getting a reply back. So my system is sending packets to it and I'm getting a reply back as such. Okay. But if I ping an IP from a different network, something like 192.168.1.10, okay, or 1.1, you can see I don't get any reply back because that's an IP belonging to a different network. The request is timing out. Okay. It's not reachable. Okay. So that's what the network and host portion signify, guys. Each network portion just denotes the identity for the entire network. And each host portion specifies the host in that network. Okay. Is that clear for everyone? Any questions, any doubts? Jeevan, Sandeep, Sumit, Vaibhav, Priyadarshini, and Sania. Others? Sandeep, any questions? Sumit, any questions? Oh, Sumit, yeah, sure, definitely. So basically, Sumit, if let me try to explain this with a simple diagram, if it is still a bit unclear. So let's assume this is our home network. Okay, so this is my home network. Okay, so now home network, you have a Wi-Fi router. So in your home network, your Wi-Fi router itself acts as a switch. Okay, so let's call this the router. Okay, and we have multiple devices in our home, right? Okay, so let's say these are all the computers that I'm connecting in my home. Okay, so to your Wi-Fi router, all of these devices are wirelessly connected. Okay, so you have connections established from your router to all these devices. Okay, so in my home network, if I have less than 255 devices, I can go for class C. So this device can, so my router will have the first IP, 192.168.0.1. Okay, and this device could be 192.168.0.2. Okay, this could be 192.168.0.3. Okay, this could be 192.168.0.4. Okay, this could be 192.168.0.5. Okay, so like that. Okay, so this could be, let's say, 192.168.0.6. Okay, now what in class C as mentioned? So class C has 3 network portions and 1 host portion. That's an important point to remember. Okay, 3 network portions and 1 host portion. So the 3 network portions give the identity for the network. So all of these belong to the same network, 192.168.0. network. Okay, since these 3 values are same, since the first 3 octets are same for everyone, that is why they're able to communicate with each other. They belong to the same network. What is a network? A network is a group or a collection of devices. Okay, so this is the first device, the second device, the third device, fourth device, fifth device, sixth device. Okay, last portion is the host portion. So host portion indicates the identity for that unique host. Okay, so 1 is for the router, 2 is for this computer, 3 is for this computer, 4 is for this computer, 5 is for this computer, 6 is for this computer. Okay, so each host portion indicates a unique host in that same network. Okay, now if I bring a device like 192.168.1.1, let's say, okay, over here. Okay, so I've brought a device here which is 192.168.1.1. Okay, now this device has the first 3 portions as 192.168.1. Okay, and if you notice, this portion here is quite different. So all the others are 0 and this is 1. So whenever there's a change in the network portion, that indicates a change in the network. And if the network portion is not same, this device cannot communicate with any other devices. Okay, oh, let me put this in orange. Okay, so this belongs to a different network altogether. Okay, So whenever there's a change in the network portion, it indicates that it belongs to a separate network and it cannot communicate with the other devices. So even if you're physically connected with a LAN cable as well, this connection is not allowed because it belongs to a different network altogether. Okay. Is it clear now, Samit? Right. Vaibhav, router assigned IP to all devices. That's right. Yeah. Okay. If I change network, then my IP will change. Yeah, definitely, Vaibhav. So right now, if you notice, if I log into my router here, 192.168.0.1, that's my router. Okay. So if I log into my router here, in my router, I can modify the IP addresses. So if I go to my network settings here, LAN settings, this is the IP I gave to my router 0.1. Okay. And this is the remaining pool of IPs I'm suggesting. So out of this pool only, it will assign the IP to each device in my network. Okay. So if I change this IP here, let's say if I change 192.168.0.1 to 1.1, then I have to change the values here also 1.2 to 1.199 or 1.255. And from that range, it assigns an IP to each device. Okay. So you have to modify all the IPs here. Okay. Only then all the other devices will be able to communicate with the router. Okay. Is that clear, Vaibhav? Right. When we buy a laptop, what class will be assigned? No, Sandeep. Please remember these are private IPs. Private IPs are in your control. Okay. So you can assign any private IP you want. But basically, the private IP that you're getting was configured by the person who set up your Wi-Fi connection. So when you took the internet connection from your ISP, Act FiberNet or Hathway or BSNL or whoever it is, there was one person who came to your house and set up the router. So that guy in the router made these settings. Okay. So he assigns the IPs in the router. So for the router, he assigns a unique IP. And this router will automatically assign IPs from this range. Okay. So it is the ISP guy, I would say the ISP technical guy or technician who assigns the private IPs to you, who sets the range of private IPs in the router. And from that range only, the router assigns a private IP to each system in your home. Okay. So it's not the laptop which gets itself. Okay. It's the person who assigned it in the router when he configured the router. Okay. Is that clear, Sandeep? Hello, Sandeep. Are you there?
Yes, got it. Thank you.
Right. Now, coming back to Class B, guys. So this is Class C. So the unique feature of Class C is you can connect a maximum of 255 devices in each class. Sorry, in each network in Class C. Okay. But what if the network requires much larger number of devices? For that, you have to go for Class B. Okay. So in Class B, you have two network portions and two host portions. Okay. So the first private IP in Class B starts at 172. Where is this? Where is this? Yeah, here, Class B. Okay. So the first private IP in Class B starts at 172.16.00. Okay. So the first two portions are network portions, last two portions are host portions. Same logic again. So after 00, we have 01, 02, 03, 04, goes up to 0255. Now after 0255, the network doesn't change, guys, because both the portions are host. So after 0255, you have 10, and this still belongs to the same network, the 172.16 network. Okay. So then you have 10, 11, 12, 13, which goes up to 1255. Then 20, 21, 22, 23, which goes up to 2255. Like that, the cycle repeats, and somewhere down the line, you'll have 2550, 2551, 2552, 2553, 255, 255. Now, when both these octets are filled, the 16 changes to 17. Okay. Same logic. As long as the host portions are changing, it just indicates a change in the host. So each of these is a unique device in the network, the 172.16 network. But when 16 changes to 17 here, that is where the network divides, which means now this is the last IP you can connect in that network. And after that, a new network begins. Okay. And now in this entire network from 1600 to 16.255.255, you can connect a maximum of 255 into 255 devices. So in each network, in each third octet here, you have 255 devices. And the third octet is repeating 255 times. 0, 1, 2, 3, 4, 5, up to 255. Okay. So it should actually be 256 into 255, but just to make it easier for remembrance, I mentioned it 255 into 255. Okay, so in each class B network now, from 1600 to 16255 1700 to 17255 1800 to 18255. So in each network, you're able to connect a maximum of 255 into 255 devices. Okay, so that is the specialty of class B. Okay, in class C, you could only connect 255 devices, but in class B, you can connect 255 into 255. And that is closely equal to 65,535, I suppose. Okay, so that is the number of devices you can connect in class B. And finally, when you come to class A, it has one network portion and three host portions. So from 10,000 all the way up to 10,255, 255, 255, that's one entire single network. And how many devices can you connect, guys? Since there are three host portions, you can connect a maximum of 255 into 255 into 255 IPs. That is the largest of all. Practically speaking, you cannot connect those many because you would have latency issues and all. But logically speaking, that's what you can connect. Okay. So each class is different because you can connect each different number of devices in each network. Okay. Class A is the largest of all. Class B is for smaller networks compared to class A. And then you have class C for the smallest of all over here, 255. Okay. Therefore, class C can be used for home networks or small organizations. And class B and class A can be used for MNC companies or larger organizations. If you want, you can use class B, class A in your home network as well. Not at all an issue. Okay. But it's just a wastage of IPs. That's all. Okay. Is that clear for everyone? What the uniqueness of each class is? Class A, B, and C. Any questions, any doubts up to this point? So this is the last topic for today, guys. Nothing further. Sanya, any questions? Jeevan, any questions? Sandeep, Sumit, Vaibhav, any questions? Priyadarshini, any questions? Yeah, Sanya. Okay. Right. Others, any questions?
This class and should be remember for, right? In
You just have to remember the logic of each class, Sandeep. So where do we use each class? Okay. Class C is only connecting 255 devices. Class B, 255 into 255. Class A, 255 into 255 into 255. Okay. So depending on the network requirement, you're changing the class. Okay. So you have to remember that one point. Okay. And yeah, definitely you have to remember these ranges as well over here. So when you look at an IP, you should figure out which IP belongs to which class and whether it's public or private. So these 5 lines of data is very important. Okay. And where will we use class A? As mentioned, Jeevan, so when you have a requirement of connecting more than 255 devices, you can either go for class B or class A, anything. Okay. So as mentioned, so class B and class A both give you a large number of device connectivity. Okay. Class B gives you 65,000 devices. Class A can give you more than that. Okay. But in practical world, you would never connect those many devices. So anything would work. Class B or class A, anything can be used for more than 255 devices. Okay. Is that clear? Any questions? Jeevan? Hello? Okay. Assuming no questions. So yeah, that's that for today's class, guys. We have discussed about class A, B, and C. Class D and class C do not have any private IPs in them, guys. So they are not used in local networks. These are special public IPs. They're not even used for your internet connections, actually. They serve separate purpose. We'll talk about that in the next class. Okay. So we'll talk about what class D and class C are. We'll talk about how do you assign a private IP to your devices. Okay. What is a DHCP server? What is a DNS server? We'll talk about all that in the next session. So tomorrow's class will be the last class for networking concepts. Tomorrow we'll be concluding all the remaining networking concepts. Okay. So an important session tomorrow as well. Please do join the session without fail. Okay. That's it. Nothing further for the session tonight, guys. We can exit the session here. Bye-bye. Good night.
thank you.
Thank you, guys. Bye-bye.